So this is the Some Atom Questions page. Getting back to this evening. So question number 1, how many electrons can be in an orbital? Remember, you've got like, if you're writing electron configurations like 1s and then 2s and 2p and so on. And then in the s there's 1 orbital, in the p there are 3 orbitals and so on. So how many electrons can be in each one of these orbitals? 2. The answer is 2. How many electrons in an outer shell of an F- ion? F is 1s2, 2s2, 2p, 5. If it's got a minus charge though, that means it's gained an electron, so instead of 5, it's got 6 electrons. So it'll be 1s2, 2s2, 2p6. The outer shell is the highest energy level, so that'd be 2. Shows up here, shows up here. So 2 plus 6 equals 8. And once again, it's that because it's an ion. Fluorine has gained an electron. How many pairs of electrons in an atom of iron? We did this one in class, but here it is. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Then if you do the orbital notation, so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So the orbital notation says that there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pairs of electrons. How many dots in the electron formula of iron? If you look at iron, it's right here. The outer shell is a 4s2, so there's just 2 electrons. If you look at antimony, though, antimony has 5 valence electrons. Let me show you really quickly how we know. And here's our periodic table. Antimony is right here. Notice it's in the 1, 2, skip these rows, 3, 4, 5th tall column. So it's an s2p3, 5 valence electrons. If there are 5 valence electrons, then you expect the outer shell to have an s and a p. So 1, 2, 3, 4, 5. So the dot diagram would have the 2 s electrons there, and then the p electrons would be singles. Dots in the dot diagrams of the noble gases. Well, once again, you go back and look at the periodic table. So in the periodic table, there are 1, 2, 3, 4, 5, 6, 7, 8 electrons in the noble gases. That didn't work so well. But anyway, here, these guys over here are the noble gases. So all except for helium, they have 8. So the answer there would be 8. And that brings us up to number 9. The energy of electrons in the same orbital is about the same. So if you have an electron in this orbital and an electron in that orbital, that's generally true. They're about the same, not exact but close. Pairs of electrons in the outer shell of polonium. So you look at polonium, then you come over to the periodic table, and polonium is right here. So how many electrons in the outer shell? 1, 2. Skip all these because those all have 2 in their outer shell. Then this column's 3, this column's 4, 5, 6. So polonium has 6 electrons in its outer shell. Or if you want to do the electron configuration, you can. So you go 1s2, 2s2, 2p6, 3s2, 3p6, follow my cursor, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2. Remember, there's this little sign here means you go down here. So 6s2, then 4f14, then back to 5d10, and then polonium's into 6p, 1, 2, 3, 4, 6p4. So before 6p, you're going to have a 6s, so there'll be 6 electrons in the outer shell. So if you write the configuration out again, polonium's outer shell is 6s2, then you got a 4f14, which is not part of the outer shell, and a 5d10, which is not part of the outer shell, then a 6p4. So 6 electrons, so here they are. Those 2 are the s electrons. Nope, I underlined the wrong thing. Those electrons. And these 4 electrons are the p electrons. So you notice I went here, then here, then here, then back to there. So that last one there is the 6th one, and that's a pair. So you got a pair, and single, 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 pair. So 2 electrons that can have in quantum, the maximum number they can have is 3. We talked about that in class, and it's on the other video as well, kind of showed you a bit. But I'll just real quickly show you with something simple like lithium. So you have 1s2, 2s2, 2p, not lithium, that's boron. This is boron. So since I went this far, we'll go to boron. B. Okay, you got 1s, you got 2s, you got 2p. Okay, so you have 1, 2, 3, 4, 5 electrons. So we'll just take a look at these 2 electrons in the 2s. So they all have the same value of n. So for those two, n equals 2. L equals 0 because it's an s sublevel. M equals 0 because if L equals 0, then M has to equal 0. But the electrons that are in there, one's going to spin clockwise and one's counterclockwise. So how many is that in common? 3. So if they're in the same sublevel but different orbitals, how many quantum numbers would they have in common? So if I was looking, let's go to carbon now. So 1s2, 2s2, 2p2. And we'll use the 2p2, single here, single here. All right, so these are in the same sublevel, both into 2p, but in different orbitals. So n equals 2. Now when I say different orbitals, you know there's one here, and there's one here, 2 different orbitals. So L would equal 1. M, though, would have to equal -1 for the first electron. The second electron is 2, 1, 2, 1, and 0. -1, 0, 1. So how many, if they're in the same sublevel but in different orbitals, they must have 2 in common. That's N and L. M will be different. They could have 3, because you could have, in this case, a positive 1/2 here and a positive 1/2 in that orbital. So that would be the same S quantum number. So they must have 2, they could have 3. Okay, how many neutrons in U-235? Oh, I skipped some questions down here, didn't I? So how many neutrons in U-235? U-235 is 92. 235. If I subtract those, I'm going to get a 3. And 13 minus 9 is 4. So it looks like 143. Okay, let's go ahead. I'll finish this column and come back to the other column. So how many electrons in a copper plus 2 ion? Copper has 29 electrons. So if you take away 2, now you're going to have 27. So 29 with a plus 2 charge is 29 electrons. A plus 2 charge means you've lost 2 electrons. So you have 27 electrons. Are positive ions larger or smaller than their atoms? Well, if I use lithium, for example, there's 3 protons, here's 3 electrons. If I want to make a positive ion, then I have to take away an electron. So if I did that, did the atom get bigger or smaller? Given that the atom kind of looks like this, and that electron's out there, so if I take him away, then the atom got smaller. All right, now back over to the other side. Now, because argon compared to chlorine, here's chlorine's electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, nope, 3p5. Chlorine would be 3p5. All right, so 2, 4, 10, 12, 17, yes. Oh, but it's Cl minus. What does minus mean? It means you've gained an electron. So does that mean we got 5 or a 6 here? It means that there is a 6. There's supposed to be right there that I'm trying to write in. Okay, that's a 6. So if that's the case, now we've got 2, 4, 10, 12, 18 which is the same number of electrons in argon. So they are the same. And the first element to have energy level overlap, 1s2, 2s2, 2p6, 3s2, 3p6. 4 is the first place because before there's 4s and there's 3d. So the overlap happens right here. So the first element to do that would be 4s1, and 4s1 is potassium. So if L equals 3, then M equals -3, -2, -1, 0, 1, and 2, and 3. 7 orbitals. Okay, I think that's all of that sheet. Happy to be able to get that done tonight.